Colors.
No, it's green, isn't it?
No, don't pull it down.
Change colors. It's supposed to be.
Yeah, no kidding.
And blue.
Oh, I didn't even know
It's
this.
ghost fires.
Uh-oh, what's going to happen to the fire now? Well, that was magic.
Now,
Why's it gone?
it's a good demonstration because when you're burning stuff, when you're trying to get energy out of things, you need two things. You need some fuel, and in your bodies, when you're eating food, the fuel is your food. But there's another thing you need too. And in chemistry, we say it's an oxidizer. And usually, the oxidizer is oxygen in air. Air is full of lots of different gases, and there's one particularly important one, oxygen, which is the stuff that you use when you're breathing. Now this substance here that I'm melting is called potassium chlorate. It's got lots and lots of oxygen in it. And that helps stuff burn. Lots and lots of oxygen in that tube now, which means anything that can burn probably will. I'm going to give that a try now. There we go.
If you touch it, you'll burn your hand.
This is a cheesy, which is fuel for you, so hopefully it'll be fuel for this too.
Oh my God!
Now to plug your ears. Oh, it wasn't too bad.
Calcium carbide is very special. I can't let you touch it because it can hurt you, but you can look at it. It can hurt you because
The gas is over
it can hurt your skin. It can burn it a little bit.
Sit down,
One thing calcium carbide will do is react with water and make another fuel. And this fuel is called acetylene. Has anybody ever heard of an oxyacetylene torch?
No.
You can burn through steel with
Well, I know a
oxyacetylene
torch
torch.
from Minecraft.
Ah, well, it's hotter than that. I love Minecraft, by the way.
Hotter than lava.
What I'm going to do is I'm going to put a little bit of this calcium carbide in there, and I'm going to catch the acetylene that comes off of it in the cup, and then I'm going to set fire to it. And we'll see what happens. So once that's in the water, it starts to fizz. And there's gas coming off now. I'm going to catch that gas in the cup.
Whoa! Oh, that was cool.
Let me try again. I didn't mean to melt a hole in the cup.
Just watch.
Plug it in. Oh, because it isn't that dangerous.
You know, if you get really good at this, you can catch the cup on the way down.
Try to do that.
I'm going to.
Plug your
Let's
ears.
see what I can do. You're smelling. This is carbon disulfide. And it's a liquid, but it's very stinky.
No, what is it?
Notice you didn't put in very much.
Just a little tiny bit is all I need.
See what happens.
So you see there's a little bit of liquid in there. I'm going to roll it around and mix it up with the gas that's in there. Because I want these two to be really well mixed.
Looks like it has some hot cheese.
Now, turn off the lights because there's a bright one in this. Here we go. Nope, missed.
It's the coolest stuff ever.
Dry ice is very, 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 very cold. This is negative 78 degrees.
Whoa, that's a bad winter day.
It's cold enough that it can burn you, but if you hold it like this and move it around, it's not too bad. I'm going to put a lump down there at the end of the show, and you can poke it with your finger, but don't hold it in your hand.
I don't like
Okay?
to.
You don't have to.
You don't have to.
You didn't wait.
Yeah. Yeah.
All right, let's see if we can make a potion.
What do we need? What is this potion?
Oh, what does that look like? It reminds me of the fog machine used at Halloween too.
I got a fog machine.
Whoa, that's cool.
You know what? If I did drink it, it probably wouldn't be very bad for me. But one thing about being in the chemistry business is you're not supposed to drink anything in the lab. You're not supposed to eat or drink anything in the lab, just in case it's dangerous. So I'm not going to drink this. One thing about this stuff, this is called carbon dioxide. Carbon dioxide is very special because it puts out fires. So there's a little fire there. I'm going to put it out using a little bit of dry ice. Now, if I warm this up a little bit with my hand, this container is filling up with carbon dioxide, and carbon dioxide is heavier than air, so I should be able to just pour it over the flame, put it out. Now, that's how lots of fire extinguishers work. So carbon dioxide is not usually something you can make burn. If you're good at chemistry, you can. I'm going to try and make this stuff burn. Now, the main thing to make something burn is that you've got to combine something that really wants to be a fuel with something that really wants to be an oxidizer. Now, carbon dioxide doesn't much want to be an oxidizer, but magnesium, which is what I just put in there, really wants to be a fuel. So, we're going to give it a try now. I'm going to try to set fire to it, and then I'm going to put this block on top, and if that was a normal fire, carbon dioxide would put it out. But this is not a normal fire.
Does this Firework! Oh my! It's Christmas! Oh! Turn off the lights!
Oh, what's on there?
Look, it's New Year's Eve! What's under it? New Year!
Is it fire still burning?
The fire's still burning inside.
I want to see it!
It'll probably burn quite a lot more if I took the carbon dioxide off, which is why I'm leaving it there for a minute. What actually happened in there is the magnesium burned and it formed. I don't know if you guys can see it.
Don't touch.
Don't touch it, boys.
Don't touch it,
Don't
boys.
touch it.
Just look.
Just look. You see there's some black stuff in the middle there. That's carbon. And the white stuff is magnesium oxide.
Those squares
See the black stuff in the middle is carbon.
So it's
White stuff is magnesium oxide.
So all the
And I'm going to leave something out there.
it smells. Something smelly around here.
There's lots of it. Now,
Which one?
this hydrogen peroxide has lots and lots of oxygen in it. And if it's given just a little bit of a kick by something like this is called a catalyst, then it will start producing lots of oxygen gas in little tiny bubbles. And that's why I put in dish detergent, because dish detergent's good at keeping bubbles from popping, right? It keeps lots of bubbles together. So we're going to catch all the bubbles and see them all come out. So if you're ready, is everybody watching?
I'm ready.